Hi, everyone. I'm Sophie.
And I'm Evelyn, and together with our teammate Ellie, we are the RAGTag Snappers. Before we get started, we want to send a huge thank you to our mentor, Michael, without whom this project would not have been possible. Okay, so our project really focused on how could we use something like Policy2Code to improve payment accuracy in DC by aiding SNAP caseworkers. And so we all know SNAP caseworkers work really hard, and with 1 in 5 DC residents eligible for SNAP and less than 1 year to ramp up new SNAP caseworkers, it's a very difficult job. And we kind of put them in a difficult situation where only 48% of all applications can even be completed by the federal timeliness mandate. And sometimes we put them in situations where they just have minutes to review really complex cases before they head into the application interview. So Michael pointed out perhaps this is a really good use case where we can use the over 40,000 existing DC data points to try to build a model to improve this process. So for those of you who aren't familiar, the SNAP case review process kind of has 4 main steps. So the first is that an application form is submitted. A caseworker and an eligibility system currently processes that application, and then the same or a different caseworker then interviews the household. And then all that information combined is finally used to determine SNAP eligibility. So the first question we asked was, can we use Policy2Code to process SNAP applications accurately? And so we thought, let's shoot for the moon. Let's see if an LLM could do this entire gray box by itself. Then the second, possibly more practical question that we ask is, how can we use an AI to assist the entire process to make it more efficient? And so Michael helped us identify several different ways that we could consider exploring the impact of an LLM. So for example, in the first step, when an application form is submitted, perhaps we could use an LLM to create a more readable text synthesis that someone could ingest more holistically. Or we could potentially ask an LLM to review the text application to identify inconsistencies that are commonly already identified by the SNAP QC data for the caseworker to follow up with during the interview. And then during the interview, now there's live transcriptions, so could you use that to kind of live identify inconsistencies during the interview that you can clarify with the application, and then ask them to update the application so when the final case assessment is made, you're able to kind of get the most accurate assessment of benefits that you can. So what did we do? To answer the first question, we built a RAG model using GPT-4o Mini, as many people here did. We used the model to calculate benefits for kind of all 259 applications that exist in the SNAP QC 2022 data. And then we used that DC data to then compare our model outputs to see how our model performed. And then separately, to kind of see if we can use LLMs to identify SNAP application inconsistencies, we tested off-the-shelf ChatGPT interface to see if there was anything that it could possibly do that people can just easily grab today. And so this video is a demo of us doing just that.
It does have sound. Is it possible to...
Do you want to talk over it?
Okay, I'll talk over it. So this is a case file that was just an example case file here, and we wanted to test out just getting a quick summary from what can be like 15 pages of case notes that the caseworker needs to review before an interview. So it just gives a really quick overview that they can then go into the interview with to ask relevant questions to the customer. Our next experiment was uploading common SNAP errors that we found in that QC data, as well as a mock SNAP application that we intentionally had errors in to see if it could compare those and identify those errors in that document. And it is able to actually identify that, give us sort of a bulleted list of what those errors might be. And so then the caseworker is really armed with that information to go into the interview and clarify those points with the customer. And this makes it really efficient, so they're not trying to go through the entire application themselves, but they can kind of identify those errors that we already know about pre-interview. And then the last thing that we did was just get that live transcription that Evelyn was talking about, and be able to compare, the things that came up in the interview that did clarify the errors that we identified in the previous step, and be able to follow up after the interview to say, like, okay, we identified these errors, then we got clarification during the interview, we can verify that with the transcript. Now, what are the follow-up steps? What are the ways in which you need to address in your application the errors that we've identified from there? So these, again, are just using the off-the-shelf models to identify just a few quick areas that can help caseworkers. Nothing revolutionary, but just seeing how this can already be leveraged with what's already widely available.
Great. So what did we learn? As a high-level summary across kind of all the use cases that we explored, LLMs are good at reading and synthesizing text, but really not good at following strict formulas. And something like calculating SNAP eligibility and final amount is a strict formula. And this is really not surprising because this is exactly what LLMs are built to do. So what we found is, like, when we fed it the SNAP regulations, it was generally correctly interpreting the rules about SNAP, and importantly, it was really good at simplifying the policy language into something that was really easy to understand. When we asked it to kind of explain how it was calculating the SNAP results, it was able to kind of tell us what it was doing in a fairly logical manner, and actually made it quite easy to troubleshoot because you could clearly say, it's doing this wrong, it's doing this wrong. And then, as you saw with the video, it was really good at summarizing long case notes into something that someone could easily digest. What it was not good at is it was very bad at interpreting vague words. So something like shelter cost. It is actually only supposed to include rent, but the LLM said that it was rent and utilities. And something like this is very important to flag because precision in these numbers is important to reduce errors. And then finally, LLMs, again, are bad at math. It did not subtract deductions in the right order, so basically found all of the calculated benefits were wrong. So in conclusion, you should not use LLMs to follow a strict formula like benefit calculation, but it's great at summarizing text. It's not going to replace subject matter expertise, but we can find interesting ways to use their strength in general tests to speed up the eligibility process. And then, just as a summary, we color-coded kind of how we think LLMs can really contribute to each of these different steps. The orange here is where we felt LLMs were really good, but you still had to kind of manually update and tell it in a specific prompt what you wanted to do. And that's all.